Designing and engineering operations to run with accuracy and consistency of a clock. Developing new tools, concurrent engineering designed for excellence. Management tools, product lifecycle management, total quality management, an extremely important tool that's been available to people for the past few decades. Personally, I've used it for 30 years and many people ignore it totally. Dilemma. Production people are going to figure out the details. They always have. So you're going to rely on what and whom to deliver results for complex operations and high-tech products and processes. Designing and engineering operations to run with accuracy and consistency of the clock is not for everybody. The key is in having experienced and conscientious technical people with the ability to explain the need for innovative, cost-effective solutions, working as a leader in your teams. The Boeing 787 Dreamliner is an example, where high-level management tried to cut costs using tools like concurrent engineering, DFX, and PLM, but it failed to sell its reasons to the employer, and therefore they ended up with quote, all in all, 70% of the 787 is being manufactured outside the United States, up from less than 2% for the 747 in the late 1960s. A reasonable guess, one that stops short of suggesting, is that Boeing is going the way of Zenith, General Motors, and other erstwhile American industrial titans that have had their clock cleaned in East Asia. There is a link for you to look at the original article. The writer of the quote article doesn't know that Boeing's management's original plan included major labor reduction, quite higher than the one implemented, and quality improvement using automation DFX PLM, but it was opposed, um, sabotaged by employees. Actually, they had a strike going on for months. Imagine, what if the components in our body were operating without a central nervous system and was controlled by one single brain? Or what do you think would happen if the body components were formed and designed to function without DNA or genetic mapping? Or if there were connection and communication gaps between the nervous system and the brain? Or what if our bodies didn't have the capability to adjust and adapt to environment? In a nutshell, we need to have systematic planning, market analysis, product benchmarking, technology benchmarking for designing quality expectations. These are methods and tools that set the foundation and enable identification and control requirements for major functional units, including design, manufacturing, as well as supplier quality. Experienced designers and engineers and adequate high-tech tools both identify and set standards and specifications for building innovative and cost-effective products are very important. Concurrent engineering supports working together, assuring alignment of both design and manufacturing specifications with customer market needs. Thorough cultural training, educating people for building confidence, trust, and respect to support proper execution of plans is critical. So is positive, proper team communication for maximizing the effectiveness of the teams working together while developing solutions. It focuses on delivering quality outputs consistently, cost effectively. So many times I've seen so many people in different companies working very hard, delivering results for their own department, for their own business units, but the results conflict with what the requirements for customer are because they conflict with what the needs for another business units are. So basically, even though one business unit is functioning great, but they are not aligning the results with other business units or the customer needs. That is overall a lack of efficiency and waste. PLM philosophy. Purpose of all popular PLM software is to provide one single tool to define and manage our elements that contribute to manufacturing products, from the conception through sale of finished goods. The purpose of having single tool to manage all is to align all specifications, inputs, outputs, and make sure that all business units are designed and operate to deliver to customer satisfaction cost effectively. Total quality management is a philosophy that supports analyzing all factors that are inputs to process and influence quality of the products in order to ensure successful quality management. TQM supports success of PLM. Dilemma. Production people are going to figure out the details they always have. That is not true. Maybe the old products where craftsmanship was controlling the quality, this would have worked, but right now the quality is controlled by incoming material. Materials are sophisticated, high tech, so are the processes. There is very little that production can do to control the quality after they have received set specifications for material or they have an equipment that is designed to run per certain specifications, which does not include the reality of what their product and materials require. So basically, if market research has not clarified the quality requirements at the beginning, product concept design wasn't done right to identify the volume, quality, and cost requirements. The supply chain wasn't done right to provide the right material, right time with the right quality, or design and development wasn't done right to develop a design where the product is robust enough for the process or the process is capable to deliver the quality, then manufacturing is not going to be able to deliver the quality. All those factors, incoming material, the equipment the manufacturing has to live with, the process designs, everything has to be determined from the very beginning. What is the requirements from the market, how the product needs to be designed, and what kind of supply chain planning we have in order to manage the manufacturing effectively and efficiently. Sales and marketing are a key factor in supporting the profit. However, service is going to fail if the components are unreliable, or sales are going to fail if the customers have repeated problems with the quality they receive or the delivery of the product. Product lifecycle management. Controlling over products quality and cost has requirements beyond software control tasks. PLM is just a software for many people. However, it should be a lot more. Market research. It's the time to identify type of product, identify the volume, identify quality expectation, identify flexibility required, and identify life expectancy of the product so they can determine the quality. Product concept design is where they define customer needs clearly, they define the quality requirements clearly, and they come up with the cost, window, minimum, maximum cost, and the quantity expectations. Supply chain is one we have to decide what are the fabrication capabilities requirements, what is the capacity requirements, what are the um, options, and perform feasibility studies. Are we going to manufacture this? Are we going to contract it? And who, how we're going to source it? We're going to make all those decisions through supply chain strategic planning. Then we design and develop the details. Innovative design ideas help us use the best material to deliver the best quality most cost effectively. It makes a huge difference what kind of material, what grade of material, what classification of materials you use in both manufacturing processes and customer needs. Many people ignore manufacturing requirements. Critical to quality specifications must be identified during design and development, and the manufacturing, the next step was to be designed to handle, to control critical to quality specs. Special processing specs. If the designers do not identify special processing requirements, manufacturing is not going to be aware of it and is not going to develop its processes to control it. Prototyping helps to identify a lot of these problems. However, in today's real world, many companies prototype just to get a shape of products or product function at the end so they can experiment whether the product is going to work. They ignore manufacturing requirements during prototyping or specifying manufacturing methods, which comes back to haunt them in the future. Concurrent engineering during design and development is what is a must have. It's too late to try to do concurrent engineering after the product is released into manufacturing. And that's not realistic. Though for some people, there are no choices like an airplane. They need to have their hands-on experience for concurrent engineering, and that's where design and experiment comes very handy, and prototyping and a lot of other methods, and makes concurrent engineering very difficult. So it's important, but it can be complex depending on the product. DFM, DFA, DOE, FMEA, DFMEA, these are all tools that can be used to support concurrent engineering. Designed for Excellence is bringing all these tools together and doing what can be done as far as running experiments, prototyping, to bring all the different expertise together to come up with the practical design that can be manufactured and serviced cost effectively. Manufacturing success depends on the methods and process controls. Quality capacity specs must be known. They cannot be left to manufacturing people. They have to be identified way back in product concept design and market research. And automation feasibility is a study that can be left to manufacturing, or even better, be done during design and development. It's one of those areas where automation is not necessarily um, important to be implemented before the product is introduced to manufacturing. However, it needs to be considered during design and development because the feasibility of automation depends on the design complexity. And design complexity can be minimized by smart product design. Minimize the requirements for using high-tech or complex equipment in order to manage the equipment itself. Justification of manufacturing processes depends on many things. It depends on the materials, it depends on the design, it depends on how you use the technology. It's complex. Justification is not just a matter of crunching numbers. It is a very technical process, and it involves bringing everything together from supplier quality to product design to manufacturing processes to how to come up with innovative designs for the equipment itself. Facilities management can be one of the most complicated operations or business units for a company. It depends on the quality of the equipment, quality of the system used to run the operation, whether it's infrastructure, whether it's service lines, or how they are managed. It's all depends on how everything is planned and designed. Materials management is another factor which is very complex, and many people are losing about 30% efficiency because of poor control over materials management, because of poor planning over materials management. It can reduce the efficiency 30% on production lines. And there are ways to get maximum quality and best most efficient way, but not everybody knows how to use it. They just don't engineer what they need to engineer. They leave everything to inexperienced people, and they think just you have to be a strong leader of controlling people in order to control the materials management. There's a logistics. There is logistics and how materials have to be managed, and people ignore that. Sales and service depend on the structured product design, and the repair and the service planning depend on the quality of the components and the structure of the product design or configuration of the product. And they can be planned and they can be controlled, but they are not planned and controlled as they should be. And I've seen situations where people are well aware of this and they use it to increase profit from repair instead of to eliminate the need for repair. Sales, repair, customer training are very, very important. There are a lot of people that are using this correctly. They have extensive training for sales, extensive training for repair and customer training. However, the weaknesses is feedback to manufacturing, as the issues with the quality, issues with the um, malfunctioning or reliability. The weakness in this area is eliminating the need for repair. Warehousing strategies are getting better actually. That's one area that the people are getting stronger and stronger, with one weakness of not controlling the quality of production, not controlling the design, ability to be robust, and having issues in manufacturing supporting the planning. Therefore, this causes problem in warehousing, mostly because of the failures in manufacturing quality. Designing and manufacturing products that use high-tech materials and processes are complicated as one ought to expect them to be. Basically, we are in a changing world. Most products these days are more complicated than anybody could have imagined 30, 40 years ago. Materials that we use, they need to deliver products within expected accuracy and reliability, and they need to have the right classification for purity and consistency. These materials need to be processed accurately within tolerances that their chemical, physical properties demanded. These materials are sensitive materials. High-tech materials are very sensitive materials. Equipment that need to deliver products with an expected quality and reliability need to be carefully designed with upfront knowledge of input variation as well as requirements for output quality and quantity. I have personally designed and managed the design and development of equipment, and the only reason I succeed in implementing, launching products and new equipment, running them, troubleshooting them successfully, and getting results for a consistent output is controlling the input variations as well as what process requirements are, what components requirements are, what system integration requirements are to control output quality. Having both right components and controlled range of flexibility and proper system integration in order to produce cost-effective quality parts are very important, because I've seen companies where they run their equipment beyond their designed range for variation, and they're forcing the equipment to perform about what it was designed to do. Yes, they can do that, but that equipment is not going to last long, and its quality output is not going to be within the expected range. There are going to be many issues, and the issues are going to get worse through time. Management who run operations that utilize high-tech materials and processes need to be able to relate market and customer needs to critical to quality areas within their business units. They need to have capabilities to set up teams that can deliver reliable products and processes and specifications, have technical know-how to manage them and change them as required. Major tools that this management can use, and when they utilize these tools are good, great tools actually. When utilized by skilled people and they're used ethically, and they can support cost-effective production of quality products effectively. The tools are major tools are product lifecycle management, total quality management, concurrent engineering, and design for excellence. Design for excellence calls for upfront evaluation of the entire product lifecycle for identifying parts and operations and all requirements in order to set up manufacturing operations that can deliver the expected customer demands cost effectively. One-time investment costs like raw material costs, design innovation, upfront concurrent engineering that supports success of DFX, capital investment for production, capital investment for facilities. They are trying to cut corners in this one-time investments without evaluating the effect on daily operation costs can be very costly, and people can make mistakes that they have to live with throughout product life cycle. That is why the daily operation costs, cost of fabrication, cost of assembly, cost of production control, cost of materials handling, and cost of facilities management have to be evaluated when making decisions for investment or capital investment. And customer needs is what has to come up front. and has to be the bottom line delivery. The product functions, reliability of quality and time availability, on time availability, and cost of service. Those have to be the foundation and the reasons we choose the um, capital equipment and the reasons we choose what processes we use and the manufacturing processes operations, they all have to be designed with the knowledge what the customer needs are, with the affirmation and commitment to delivering those reliability and quality expectations. Author: designing and engineering operations to run with accuracy and consistency of a clock. Mahzad Pakzad, an experienced manufacturing engineer, methods engineer with experience in designing products, processes, extensive project management experience, an excellent problem solver, very good materials engineer, material science, understanding of material science, and preventive maintenance, strategic planning, operations management, systems engineering, technology transfer, and training people how to use all this. Over 30 years using philosophy to plan the quality and strategic planning of production requirements in order to develop both products and processes and manage capital equipment. It's no secret to those with experience that you need multi-skilled and high-tech professionals to help the team with making the right decisions. Mahzad has over 30 years. I have over 30 years experience doing so, and it's been a challenge, and it's been very difficult, but it's been very rewarding for me to get results where others fail to do so.